So in this video, we're going to be looking at how do we solve trig equations without a calculator. So this is using our special angles. So that means that all of these equations will work out to special angles, like 30, 45, 60, that kind of thing, and multiples of those. So here's a very simple one to start with. 1 is equal to negative 2 sine theta. Your first goal is going to be to make this look like sine theta equals k. You want to clean up the sine theta. So you just have sine theta on one side, then it equals some number on the other side. So this negative 2 is a problem. So we want to get rid of him. Do that by dividing both sides by negative 2, right, because he's being multiplied. And that gives you negative 1/2 equals sine theta. We'll just write it forward so it looks prettier. So sine theta equals negative 1/2. And that is the equation that I'm solving. And you can solve that on your unit circle. So we go over to our unit circle and we are dealing with sine here, right? So sine is equal to the y value. So on your unit circle, you're going to be looking at a y value of negative 0.5. You'll draw the 2 points on the unit circle that have that y value. They're right there and there. So you can draw them there and there. And then this is where you have to, you won't be using the same rules that we used before. So when we were doing this with our calculator, we would find sine theta 1 is the inverse sine of negative 1/2, and then our rule for theta 2 was 180 minus theta 1, and our rule for theta 3 was theta 1 plus 360. So that's how we do it on our calculator, right? But we're actually not going to be doing that here because we can use our special angles because negative 1/2 is a special angle. So that means that we can figure out where is the 30, 45, or 60 degree angle. And if you remember, there's a special triangle right here. And this, if this side is a half or negative 1/2 here, that other side would be root 3 over 2, and this must be a 30, 60 degree triangle. So this must be 30 degrees in there, that little angle right there. And there's another one right here. So this must also be 30 degrees in there. Okay, then how do I write down these angles? Let's do this one first, which is the angle measured from the positive x-axis all the way to there. So let's call that our theta 1, the first angle I want to solve for. Well, that theta 1 I would get by going all the way to 180 and then adding another 30. So that theta 1 must be 180 plus the little 30 that I see from that triangle, which is 210 degrees. And that's my first solution here. The other angle, I'll do it in black here, so that would be all the way to this arm from the positive x-axis, so going from here all the way around to here, so that's theta 2. You can see in that case, it's like going all the way to 360 and then backing up by 30. So theta 2 must be 360 minus 30. So there's not neat and tidy rules like there was before when we were doing this with our calculator. It's more just looking at the picture to try and figure out what those angles are. So theta 2 would be like going all the way around to 360 and backing up by 30, which here would be 330. All right, here's a slightly trickier one. So we're gonna have to do a little more algebra first to solve this. I need to make this look like sine theta equals k, right? So I need to get all the sine thetas together. I need to collect like terms. So probably a good start will be, I'll write out my equation again. Now in this case, I actually don't have a theta, I have an x in the equation, which is fine. It's the same idea, it just means your angle. So sine squared x is the same idea as theta. The first thing you want to do is move all the sine squareds to one side. So this one's being subtracted, so maybe it's a good one to move. So let's add sine squared x to this side and add sine squared x to that side. Well, that's going to cancel the sine squared x's there, and we'll be left with sine squared x minus 1 plus another sine squared x. And on this side, we'll just have 0, right? Minus sine squared plus sine squared, those are just gone. I can collect my like terms over here. So I have sine squared plus sine squared, that makes 2 sine squared x. Minus 1 equals 0. And then I could move the 1 to the other side, so I could subtract 1 from both sides. And that gives me 2 sine squared x is equal to 1, and then divide both sides by 2. Get rid of the 2, so now I have sine squared x equals 1/2. Now I need to get the sine x on its own. I don't want just sine squared, I need it to be just sine x. So what I can do next is actually square root both sides. Square root that side, square root this side. And that gives me sine of x is equal to the square root of 1 over 2. The square root of 1 is just 1. Square root of 2 is root 2. That's actually not my full answer. Be really careful here. So remember, if you square root, say a number like 25, the answer to that is 5, but it's also negative 5, right? Because if you do negative 5 times negative 5, you'll still get positive 25. And the same is true here. When we're square rooting 1 over 2, we get a positive, but we also get a negative answer, and both of those are going to matter here. So I'm going to write those two on the side here. Your two solutions are that sine of x will equal positive 1 over root 2, but also that sine of x will equal negative 1 over root 2. We're going to need to solve for the x values for both of those, which is actually going to be 2 solutions from this one here and 2 solutions from the second, or 4 solutions altogether. Right, so I'm going to need some more space, so I'm just going to erase this to give you more space. Here we go. And I'm going to redraw my unit circle because I think that one's just a little too small. So let's draw a really nice big one so you can see all these angles on here nicely. All right, starting with the purple ones. So when sine of x is equal to 1 over root 2, we have to remember what special angle that is. 1 over root 2 is about here, and it makes a special angle 45 degrees. So when I draw those two angles, right in here, this triangle right there is a 45-degree triangle. So that actually gives me my first angle right away. The x1 value here is going to be that angle, the x1 is right there. It's going to be the angle to that first line, which is just 45 degrees. So I'll get x1 is 45 degrees. The next one would be x2, and that's the angle all the way to over here. So that's going to be my x2 here. And what you want to notice is that there's a 45-degree triangle here as well, right? So that's a 45-degree triangle. So x2 must be 180 minus 45. So x2 is going to be 180 minus 45, which is equal to 135 degrees. So those are 2 solutions so far, but there's more. We have to do the solutions to this equation, sine of x equals negative 1 over root 2 as well. Well, negative 1 over root 2 is down here, so that would give me these points right here and here. So those are the 2 angles that solve the equation sine x equals negative 1 over root 2. Let's do this one first. So this will be x3 here. Notice that I've got another 45-degree triangle right in here. That's a 45-degree triangle too because of my special angle. So x3, oh dear, I'm running out of proofs. I'll do it over here. X3 must be equal to 180, right? Going all the way to 180 and then adding another 45 plus 45. So that's going to be 225 degrees. So x3 is 225 degrees. And then the very last angle, I would go for my positive x-axis all the way around to this last arm. What you want to notice is that you have a 45-degree triangle in here as well. That's 45 degrees too. So for x4 there, my last one, x4 must be 360, going all the way around the whole circle and then backing up by 45 degrees, so minus 45, or 315 degrees. So what we found are our solutions here. Solutions will be our x1 is 45 degrees. Our x2 is going to be 135. Our x3 value we found was 225. And our x4 is 315. So there's actually 4 answers to this equation here that are between 0 and 360 anyway. All right, the very last one, this one's quite tricky. So here, I can't collect my like terms very easily. The problem that you should notice is that I've got a sine squared and a sine theta, and then a constant. So sine squared and sine theta are not like terms, right? Those are different terms. It's like adding an x squared and an x. You can't do it. Those are not like terms. But what we do have here actually is a quadratic, right? We've got a squared term, we've got a linear term, we've got a constant, and it all equals 0. That's a quadratic equation. We just have to make it look more like a quadratic equation so we can factor it. So the move that we use here is we say that we pick some variable, any variable you want. I like m, and we define m to be sine theta. And then we replace all the sine thetas with an m. So this equation is going to become 2, and then instead of sine squared theta, it's going to be m squared, because sine theta just became m. And then instead of minus sine theta, it'll be minus m, and then just minus 1. And that equals 0. Our next plan is to factor this. So remember back to your first unit, how do we factor? We'll do 2m. I'm using triple play because I like it. All over 2. Looking for numbers that multiply to -2, so multiply to a times c, right? And add to -1, that would be -2 and +1. -2 times +1 gives me -2. -2 plus 1 gives me -1. So that all checks out. Then you want to pick one of those factors to divide by the 2. It makes sense to do the first one. So we'll do that. 2m minus 2 over 2 is going to make m minus 1. And then here we've got 2m plus 1, all equals 0. Okay, then we remember, okay, m was just a placeholder so that I could factor this thing. So let's bring back the sine theta again. So this first factor is actually sine theta minus 1. And the second factor must be, 2 sine theta plus 1 equals 0. Then we have to remember, well, how do we solve an equation like this? When you have a quadratic that you've factored and you're trying to solve for usually x, but in this case I'm solving for theta, I have to set each factor equal to 0 and solve for theta from there, or usually solve for x, but now it's theta. So let's set this first factor equal to 0. So sine theta, I'll just do that over here, sine theta minus 1 equals 0. So that's that first bracket we're setting equal to 0. Rearrange so that you get sine theta on its own. This one's actually not too tricky. I just have to add a 1 to both sides. So I get sine theta equals +1. And that is my first sort of solution. I've got it down to that, my goal, right, which is always to have sine theta equals some number. So that's good. I've gotten there. Now I set the next bracket equal to 0. So your next bracket is 2 sine theta plus 1. We have to set that equal to 0. So 2 sine theta plus 1 has to equal 0. Well, let's move the 1 first again. So I'll subtract 1 from both sides. That's going to give me 2 sine theta equals -1, and then divide both sides by 2. And that gives me sine theta equals -1/2. So that is my next expression, nicely rearranged for sine theta. All that work, we're still not done yet. We have to actually solve for theta, right? So next I need to draw my unit circles out in order to calculate theta for each of these. So let's start with the first one here. We'll draw a nice unit circle for that. So the first one is that sine theta is equal to 1 here. So remember, sine is the y value again. So y is over here, and y is all the way at 1. So that's right at the top here. It's It's actually only 1 point when sine theta equals 1, and it's just right at the top. So this is a special angle as well, and you can read it right off this unit circle. That angle, that theta right there, is equal to 90 degrees. So the very first solution we've got here comes from this one, and that is that the angle theta equals 90 degrees. So that's my first answer to this problem. All right, next I need to draw another unit circle to do my -1/2, or maybe I can fit it on the same one. Let's see if I can fit it on the same one. So -1/2 is down here. It's -1/2. So 2 points with that value would be here and here. So here you need to remember your special angles again. So this is a little triangle. It's a 30-degree triangle in here, and this is also a 30-degree triangle here. So let's see what those two angles must be. We measure our angles from the positive x-axis, so going over here to this one, let's do that one first. So maybe I could call that theta 2. Well, theta 2 looks like I'm going to 180 and then adding 30. So it would be 180 plus 30, which is 210 degrees. So that's another solution to this. And the very last one, theta 3, I'm going to go all the way around here. There's theta 3. Theta 3 looks like you're going all the way to 360, right? And then backing up by 30. So that would be 360 minus 30, or in other words, 330 degrees. So those are my three answers. 90 degrees, 210 degrees, and 330 degrees are the three solutions to this quadratic.